Howdy folks, welcome back. So in this video, I'm just going to quick go through the final unit practice test, so practice test 4. So we have this test and then the final after this. So again, as usual, these are just the ways that I would go about solving problems. Again, I recognize that they are by no means the only ways, and in some cases, they might not even be the best ways or the ways that make the most sense to you. This is just to give you an idea if you're curious as to how to go about starting to solve the problem. This is just how I would do it. And again, you can find this practice test on the Pearson website. In the assignments, you should see practice test 4 listed there. So with no further ado, let's go ahead and get started here. All right, so this first question is dealing with graphs of sine and cosine functions. So it's given a graph of a sine wave, determine the function that produced that given graph. All right, so here we have kind of the setup. So we have scientists use the same types of terms to describe ocean waves that we use to describe sine waves. So the period is the time between crests. So the period is the time between the two high points. The wave height is the vertical distance from the trough to the crest. And the accompanying figure shows a swell in a coordinate system. Write an equation for that swell, assuming that it is the shape of a sine wave. All right, so again, with this, we have kind of 3 parts. So part 1, 2, and 3. I suppose technically, in this case, we might have 4, since we might be dealing with a vertical shift as well. All right, so the first part is, again, determining whether we're dealing with a sine or a cosine function. Here, since we're given that it's a sinusoid, it kind of answers that first question for us. So it's going to be a sine wave. All right, the second part here is going to be dealing with the amplitude. So what we multiply in front of our sine function. All right, so to find your amplitude, you're just going to take your high value minus your low value. So in this case, the crest is going to be 4, and then my low value in this case is going to be 0, and divide that by 2. So we have 4 minus 0 is going to be 4, divided by 2 is going to be 2. All right, so that is going to be the number in front of my sine function, so my coefficient in front of my sine function. The third thing here is dealing with the period. All right, so the period is going to be 2 pi over b, where again, b is whatever I'm multiplying inside my function definition there. All right, so in this case, the period again is going to be the distance between crests. All right, so here I have one crest is at 5, and the next crest is at 25. So that tells me that my period is going to be 20 seconds. So we have 2 pi over b equals 20. So you want to solve for b here, so we can multiply both sides by b, divide by 20. So we have b equals, here the 2 and the 20 will cancel. The b's are going to be gone, so we have pi over 10. And again, that's what I'm multiplying in front of, or inside my sine, inside my function definition there. And the final thing is, in this case, if we're dealing with a vertical shift, so there won't be a horizontal shift, but in this case, there is going to be a vertical shift. Again, generally the sine function goes through the origin, so the point 0, 0. In this case, that where it starts is actually at the point 0, 2. So we're shifting everything up 2 units. So when all is said and done here, we have y equals my amplitude, which is going to be 2 sine of pi over 10 times x. And it's really important that you remember to put the x in there. That's one of the most common mistakes that people make on this question is they forget the x. But you do need to have your variable, your independent variable in your function there. All right, and then we're also going to add 2 on the outside, since again, we're shifting up 2 units. All right. Okay. So yeah, so that's kind of it for the section 5 questions. So I didn't really focus too much on the um, questions dealing with graphs of like tangent, cotangent, cosecant, secant, all those types of functions. Partially because I don't really care for graphing questions. Yeah, that question that we had, the previous question here, was kind of the main types of questions I like to ask from those sections anyway. So yeah. So now we're kind of jumping ahead to section 6, which deals with trigonometric identities. So this first one here, so we have sine of x over cosine of x, plus 1 over secant squared of x. All right, and we're asked to write the expression in terms of sines and cosines and then simplify. All right. So yeah, so to start off, so we have sine of x over cosine of x, and then this 1 over secant squared of x. So that's the same as 1 over secant of x squared, which 1 over the secant of x. So the secant is 1 over the cosine. So 1 over the secant is going to be the same as cosine. So we have plus cosine squared of x. All right. Oh, this is actually cosecant. Sorry. I was like, I thought it would simplify more than this. All right. But yeah, so then you can also simplify this. So we have 1 over cosecant is going to be sine. So this is going to be sine squared of x. The sine over cosecant of x. I'm again kind of going off to the side here. So we have sine of x times 1 over cosecant of x, which again, 1 over the cosecant is going to be sine. So you have sine of x times sine of x, which is going to be sine squared of x, plus cosine squared of x. All right, so we have sine squared of x plus cosine squared x. And by the Pythagorean identity, so again, one of the formulations for the Pythagorean identity is if you have sine squared plus cosine squared, that's going to end up equaling 1. And I think that I will go ahead and give you kind of the basic identities. So I'll give you the reciprocal identities, the identities from the definitions, as well as the Pythagorean identities. So you don't have to memorize those. You just have to know how to use those. All right. All right. So yeah, so here we have showing that something is not an identity. So here we have sine of 2 alpha. So my candidate here is sine of 2 alpha equals to sine of alpha cosine of alpha. And we need to find the value for alpha that can be used to show that this is not an identity. So again, to prove that something is not an identity, you just need to find a single value for which that the equation does not hold. To prove that something is an identity, you have to show it for every single possible value that the person can think of. So yeah, so proving something is not an identity is most of the time easier than proving that something is an identity. All right, so here we just need to find one value for alpha where this equation is not true. All right, so this is a matter of just kind of plugging and chugging into a calculator and finding the ones that make it not true. All right, so when I plug in pi over 4 in for alpha, I have sine of 2 times pi over 4, so that's going to be the sine of pi over 2, which is going to be 1. All right, and then if I take the sine of pi over 4 times cosine of pi over 4, I think I end up with something that is not 1. All right, need to make sure that my calculator's in radians. All right, so you have sine of pi over 4 times cosine of pi over 4. Yeah, that ends up being 1/2. which is not 1. Whereas if I chose pi here, sine of 2 pi is going to be 0. Sine of pi is 0, so 0 times anything is going to be 0, so that's going to work out. Likewise here, when I take pi over 2, plug it in for alpha, sine of pi is 0. Cosine of pi over 2 is going to be 0. So again, 0 times anything, so we end up with 0 equals 0. And likewise for d there. So the one that does not work, or the one that leads to these two expressions not being equal to one another, is A. All right. This next one, again, for questions dealing with trigonometric identities and using trigonometric identities. A, I will give you the trigonometric identities that we talked about in class. B, kind of how I like to ask these questions is I like to give you a little bit of a skeleton of the proof and then have you kind of fill in some of the details, again, using the trigonometric identities, as opposed to just letting you loose on a problem without giving you any guidance whatsoever. All right, so the main thing to kind of keep in mind is what is changing between these. And you kind of choose the appropriate response to that. All right. So here we have 1. We want to prove that 1 plus tangent b times cotangent to the third of b is equal to cosecant squared of b. All right, so here the 1 is staying the same. So the one thing we're looking for is something to replace our tangent. So tangent in this case is going to be 1 over the cotangent because we have those reciprocal identities there. All right. So we have 1 over cotangent of b, and then to rewrite cotangent to the third, that's the same as the cotangent times cotangent squared. So that's second part there. All right, so there the cotangents will cancel out. So we have 1 plus the cotangent squared of b, which is equal to cosecant squared of b. So yeah, so again, just kind of follow the logic. It's not overly difficult there. All right, so here I have another example, kind of the same type of problem, just using different trigonometry identities. So again, I'm not quite sure what I'll be asking you on the actual exam. So again, I wanted to cover my bases. So chances are there's probably only going to be one of these where you have to verify the identities on the exam. I think there might be 2 or 3 in this practice exam using different trigonometric identities again there. All right. So yeah, so again, the main thing is just kind of follow along, determine what's different and what your identities say are equal to the expression that's changing here. All right, so here you want to prove that sine to the third plus sine of a, cosine squared of a divided by cosine of a is equal to the tangent of a. So yeah, so here the thing that's changing is my cosine squared. So I'm looking for the thing that is equal to cosine squared. So that's going to be 1 minus sine squared. Again, using the Pythagorean identities there. All right, so then, yeah, in this case, I distribute the sine through. So we take sine times 1 is going to be sine. And then sine squared times sine is going to be sine to the third. So we have sine of a minus sine to the third of a. All right, so then we have sine to the third minus sine to the third. So that's going to cancel out. So we're just going to be left with sine of a over cosine of a, which sine of a over cosine of a is equal to the tangent of a, which is what we were trying to prove. So again, just kind of follow along, just kind of step by step, and hopefully that leads you down the right path there. All right. So yeah, so here we have 1 minus secant of theta minus 1 over secant of theta minus tangent of theta. We want to show that that is equal to 1 plus sine of theta over cosine of theta. All right. So here it looks like what's changing is I'm multiplying the top by secant of theta plus tangent of theta, which means I have to multiply the bottom by that same thing. So when I take secant of theta minus tangent of theta, and multiply that times secant of theta plus tangent of theta. So I'm going to end up with the difference of squares here. So that's going to be a secant squared minus tangent squared, I believe. Yep, because the two middle terms, which are the combinations of secant theta, tangent of theta, are going to cancel out. And yeah, that. All right. All right, so then what is going on? Bring out a -1. I think that's what's going on. All right, so this one I might have to actually write down and see what we're doing. Because here they're not giving you anything to work with. All right, so you have secant of theta plus tangent of theta over secant squared theta minus tangent squared theta. All right. There we go. So what I think is happening is we're bringing out no, we're not bringing out a -1. All right. Ah. This is where having the trig identities handy would be helpful. But yeah, I think one of the trig identities, we have sine squared plus cosine squared equals 1, which if we divide everything by cosine squared, we end up with tangent squared plus 1 equals secant squared. So if you subtract a tangent squared from each side, we end up with secant squared minus tangent squared, which is what we have down here, is equal to 1. All right, so the secant of theta plus tangent of theta over 1 is just going to be secant of theta plus tangent of theta. All right. Takes you a while, but eventually I come up with what we're doing. All right. All right, so the next thing here, so secant of theta is going to be 1 over cosine. So that eliminates these two. So what we're left with is 1 over cosine of theta plus sine of theta over cosine of theta. Yep. Which we can add the fractions, and we end up with 1 plus sine theta over cosine theta, which is what we were trying to show. All right. That was a little bit more difficult than the previous ones there. Okay. So the next problem here is dealing with solving oblique triangles. So with solving oblique triangles, we have either the law of sines or the law of cosines. All right, so setting up, so we have 61 degrees, 63 degrees, and gamma, and we have A is 14.5. All right, and this is B, and this is C. All right. So our first step here is we can find our gamma using the sum of the angles and interior, or the interior of a triangle. So in this case, we want our calculator set to degrees. All right, so we can take 180 minus my other two angles, and that will give me my third angle. So you have 180 minus 61 minus 63. So you have 56 degrees for gamma. All right, and then we can use the law of sines to find my two sides. All right, so to find b, the law of sines says that if I take b divided by the sine of the angle opposite b, so we have b divided by a sine of 63 degrees here, that's going to equal my side A divided by the sine of my angle opposite side A. So we can multiply both sides by the sine of 63 degrees. So we have 14.5 sine of 63 divided by sine of 61. So we end up with b equals 14 point, so it's round to the nearest tenth, so we have one decimal place, so I got 14.8. And we can use a similar process to find side C. So here we have C divided by the sine of the angle opposite C, which is 56 degrees, equals A, 14.5, divided by the sine of angles opposite A, which would be 61 degrees. So you multiply both sides by the sine of 56 degrees. 14.5 sine of 56 divided by sine of 61. And I get C equals 13.7. All right. This next question is dealing with the area of a triangle. So if you have a triangle, the area is going to be 1/2 two sides, the product of two sides. So we have A times B times the sine of the angle included between the two sides. So times the sine of C. All right. So in order to find the surface area, we're just going to add up the areas of my two individual parts together here. Or it looks like you can just take 2 times the area of one of your triangles. All right. So in this case, the area of one of my triangles is going to be 1/2 two sides, the product of two sides. So we have 22 times 14 times the sine of the angle included between those two sides, which in this case is going to be 50 degrees. And then we're taking that by 2, so you can kind of ignore that 1/2 since we have two triangles of the same area. So we have 22 times 14 times the sine of 50. So we end up with 235.9. So that's round to one decimal place. So yep. 235.9 square inches. All right. All right, so here I have another problem where we're asked to solve an oblique triangle. In this case, we're given all three sides. So I'll go ahead and draw what we have here. So we have alpha, gamma, and beta here. So here we have side B is 14.1. Here we have side A is 25.6. And here we have side C is 20.2. All right. And we need to find our three angles. All right, so to find our first angle, we're going to use the law of cosines. All right, so again, what the law of cosines says is if I take the square of one of my legs, So I'll just start with a. So if I take a squared, that's going to be the sum of the squares of my other two legs. So it's going to be b squared plus c squared minus twice the product of those two legs. So minus 2bc cosine of the angle included between those two. All right, so in this case, the angle included between those two is going to be my angle alpha. So that is what I'm trying to solve for. So I'm trying to find this angle alpha. All right, so I'm just going to plug in the information I have here. So we have a is 25.6. So you have a squared is going to be that squared equal to 14.1 squared plus c squared, which is 20.2 squared, minus 2 times bc, which is 14.1, 20.2, and I have cosine of alpha. All right. So yeah, so just simplifying, just squaring everything. So 25.6 squared is 655.36. If I take 14.1 squared and add 20.2 squared, that's going to be 606.85 minus, so if I take 2 times 14.1 times 20.2, so you get 569.64, and then we have cosine of alpha still coming along for the ride there. All right. So you can subtract 606.85 so you have 655.36 minus 606.85. So you have 48.53 equals negative 569.64 cosine of alpha. Divide both sides by negative 569.64. So you have divided by negative 569.64. So you have about negative 0.08519.4 dot dot dot. That equals the cosine of alpha. So to find alpha, we can just take the inverse cosine of both sides. And when we do that, we end up with alpha equals, so I take the inverse cosine of my answer there. And if with alpha equals 94.89. All right. So yeah, so we're on to one decimal place, that would be 94.9. All right. So that's how you can find your angle alpha. Once you have one of your angles, then you can use the law of sines to find another angle. So I'll just use the law of sines to find my angle beta. All right, so we have sine of beta over side B, which is going to be 14.1, is going to be the same as the sine of alpha, which is 94.89, over side A, which is 25.6. So we can multiply both sides by 14.1. So I take 14.1 sine of 94.89 divided by 25.6, and with sine of beta equal to about 0.54878. And then we would be 0.77, and so on and so forth. All right, so now I can take the sine inverse of this answer to get my angle beta, which I get 33.3. 33.28, which is, yeah, it's going to be 33.3, rounded to one decimal place. And then once I do two angles, then I can do the fact that the sum of my angles should be 180. So you can take 180 minus my other two angles. You get 51.8 for gamma there. All right. Here we're asked to find the area of a triangle if we have the sides are 17, 9, and 9. So to find my area, I can start off by finding the semi-perimeter, which is going to be 1/2 of A plus B plus C. And then my area is going to be the square root of that semi-perimeter. The semi-perimeter is minus A times the semi-perimeter minus B times semi-perimeter minus C. All right. So to start off, I can find my semi-perimeter. So we have 17 plus 9 plus 9, all divided by 2. So that gets me 17.5 for my S. And my area is going to be square root of my answer times my answer minus each side. So we have minus 17 times the answer minus 9 times the answer minus 9. So I end up with area of 25.14. That's the nearest tenth, so that would be 25.1. All right. So the next thing we talked about here is dealing with vectors and operations with vectors. So here we have a vector A. The components of that vector are 2, 4. And we have a vector B whose components are -1, -3. All right. And we're asked to find the magnitude and direction of the vector A plus B. All right. So when I add up the two vectors, so I take A plus B, I can just add up the components. So you have 2 plus a -1 is going to be 1. And then 4 plus a -3 is going to also be 1. All right, so the magnitude of vector A plus B should be denoted by these double bars here, so that represents my magnitude of my vector, is going to be the square root of the sum of the squares of my components. Because again, what we're looking at here is we have 1 and 1. So this is my vector here. So the magnitude is going to be this distance here, which again, we have a right triangle. So we have 1 squared plus 1 squared, square root of that is going to be my magnitude. All right. So I take 1 squared plus 1 squared, so that's just going to be 1 plus 1, so that's just going to be square root of 2. Which I don't know if it wants an exact answer. Yeah, so it asks for a decimal approximation. So square root of 2 is going to be like 1.4. Yeah. All right. And then for direction, we just need to find this angle, we'll call it alpha. All right, so in this case, we're going to use the inverse tangent. So we have the inverse tangent of 1 over 1. So you have the inverse tangent of my opposite divided by my adjacent. So the inverse tangent of the second component divided by my first component will give me my angle there. All right, so we take the inverse tangent of 1 over 1. That gets me 45 degrees. All right. After this, we kind of took a step forward and talked about systems of equations. So this is dealing with solving a system equation. So to solve the following problem using two variables in a system of two equations, solve this system by the method of choice. So again, that means that you can either use substitution or elimination. the method doesn't really matter too much. All right, so you have a city zoo has different admission prices for adults and children. So when 3 adults and 2 children visit the zoo, all right, so we have 3 adults plus 2 children. The bill is going to be $80.60. All right, if 2 adults and 3 children visit the zoo, then the ticket price is going to be $76.95. All right, so we're asked to find what the price of an adult ticket and what the price of a children's ticket is going to be. All right, so this is what we're looking at here. All right, so I'm just going to label this equation 1 and this equation 2. All right, so to solve this, we can either use substitution or elimination. Since I don't have a coefficient of 1, I'm going to go ahead and use elimination. But again, you can also get a coefficient of 1 by dividing either by 3 or 2, any of your, either of your equations there. And you can use substitution if you feel so inclined. I'm going to go ahead and use elimination, but again, that's just my personal preference. That's just how I would go about doing it. All right. So to eliminate one of my variables, it looks like my least common multiple is going to be 6. So I'm just going to take 2 times equation 1 and then subtract 3 times equation 2. And that's going to get me a new equation here. All right, so when I take 2 times 3, that's going to be 6, minus 3 times 2 is also going to be 6, so those are going to be eliminated. 2 times 2 is going to be 4, minus 3 times 3, so we have 4 minus 3, or minus 3 times 3. So we have 4 minus 9, which is going to be negative 5 times c. And then when I take 2 times 80.60 minus 3 times 76.95, end up with negative 69.65. So I can divide both sides by negative 5 to get a children's ticket price of, cleared it. All right, 69.65 divided by negative 5, 13.93. All right, and then to find my adult price, I can just plug that into either of my equations up here. So I'll go ahead and use this first equation. So we have 3a plus 2 times 13.93 equals 80.6. Should take 80.6 minus 2 times 13.93 divided by 3 gets me $17.58 for the adult price. And just to make sure, I'm just going to plug that into my second equation here just to make sure I got the right answer here. So we have 2 times 17.58 plus 3 times 13.93 gets me $76.95. All right. So yeah, so again, nice thing about these problems is you can always go back and check in the terms of the original problems, and you should end up with the right answer there. All right. So the system of equations has a single solution. Yep. So the adult ticket price is $17.58, and the children's ticket price is going to be $13.93. All right. So here we have a system of 3 equations. Oh, great. X plus y plus z equals 8. 2x plus 5y plus 2z equals 22. And we have negative x plus 7y minus 3z equals 0. So I'll call this equation A, this equation B, and this equation C. All right. Okay. So yeah, so again, to solve this, we can either use substitution or elimination. I'm going to go ahead and use elimination. So to start off, I'm going to go ahead and eliminate my variable x from A and C. So to do that, we can just take equation A plus equation C. And that's going to get me, so I'm going to take x plus a negative x, that's going to be 0. Y plus 7y is going to be 8y. And then z plus a negative 3z is going to be minus 2 times z. And then 8 plus 0 is going to be 8. All right. And then I'm going to take, then you need to eliminate the same variable from your other equation. So from equation B here. All right, so to do that, I'm just going to take equation B plus 2 times equation C. So here we'll have 2x minus 2x, so that's going to eliminate the variable x there. Then we have 5 plus 2 times 7 is going to be 14, so that's going to be 19y. And then 2 plus 2 times the negative 3, so that's going to be 2 minus 6, so that's going to be minus 4z. And then we have 22 plus 2 times 0 is going to be 22 there. All right. All right, so I'll call this equation D and this equation E. All right, now we can just eliminate from these two equations. So now we have a system of 2 equations. All right, so to do that, I can go ahead and take 2 times equation D and subtract equation E. So 2 times 8 is going to be 16 minus 19 is going to be negative 3y. And then 2 times negative 2 is going to be negative 4 minus a negative 4 is going to end up eliminating the variable z. And we have 2 times 8 is going to be 16 minus 22 is going to be negative 6. Yeah. All right, and then we can divide both sides by negative 3. So you end up with y equals 2. All right. And then we just plug our way back to the original there. All right, so if y equals 2, we can use either of these two equations to solve for z. So I'm just going to go ahead and use equation D here. So you have 8 times 2 is going to be 16 minus 2z. So 8 times 2 minus 2z is going to be 8. So you have 16 minus 2z is going to be 8. So you can subtract 16 from each side. Negative 2z equals negative 8. Divide both sides by negative 2. We end up with z equals 4. And then we can use either of these first 3 equations to solve for x. So I'm going to go ahead and use the first one. So you have x plus 2 plus 4. So you have x plus 6 is going to equal 8, which implies that x equals 2. All right, so in this case, there's a single solution. So we have x is 2. My y is going to also be 2, and then my z is going to equal 4. So the next thing we talked about, we're dealing with polar coordinates. So again, with polar coordinates, you have, instead of having an x coordinate and a y coordinate like our Cartesian coordinate system, with polar coordinates, you're given a quote unquote radius, so you're given a distance, as well as a directed angle for that. All right. So yeah, so here we have the polar coordinates of 4, negative 90 degrees. So to start off, we go to negative 90 degrees. So that means that we're looking for along the y-axis, below the x-axis here. All right, and we want 4 units in that direction. So in that case, that corresponds to my choice B here. So yeah, so if we zoom in, so yeah, so again we have -90, so that means we're dealing with, again, we're moving in a clockwise direction, 90 degrees, so that means we're looking down here, and we're given 4 units in that direction. All right. So here we have the polar coordinates -3, 115 degrees. So again, what that's going to correspond to, so you have 115 degrees, so that's going to be over here. So in between 90 and 180, and then it's -3, so that means we're looking at it moving in the opposite direction. So generally our vector would be over here, and this is going to be going -3 units. So yeah, so our distance would be 3, and then our angle would be the 115 on there. So this is the point that we're looking for about. All right. So to find the coordinates, we can use the fact that x equals r cosine of theta and y equals r sine of theta. All right. So in this case, my r is -3, and then my cosine, and then my theta is 115. So my x is going to be 1.2679. And my y is going to be r, so -3, sine of 115. So my y is going to be -2.7189. All right, so it's round to the nearest tenth. We have 1.3, comma, -2.7. All right, this next one is dealing with another way of representing a line. So we talked about Cartesian coordinates, we talked about polar coordinates. So another way that you can represent points on a coordinate system is by using parametric equations. All right. So here we have the parametric equations: x equals 5t minus 8, and y equals t plus 6. So we have x equals 5t minus 8, and we have y equals t plus 6. And we have t is going to be in between 0 and 4 inclusive. So yeah, so to start off, we're asked to find which line corresponds to this. All right. So again, to find this, we can find our x and y values. So we can have t be 0, 1, 2, 3, and 4. All right, and to find your x and y coordinates, you're just going to plug these values in for t in your x and y equations there. All right, so when t is 0, we have x is going to be -8, and y is going to be +6. When t is 1, we have 5 times 1 minus 8. That's going to be -3. And we have 1 plus 6 is going to be 7. When t is 2, we have 10 minus 8. It's going to be 2. Then we have 2 plus 6 is going to be 8. And t is 3. We have 15 minus 8, which is going to be 7. And 3 plus 6 is going to be 9. And when x is 4, or when t is 4, we have 20 minus 8, which is going to be 12. And then 4 plus 6 is going to be 10 there. All right. So looking at our 3 lines here for our possible options. All right. So you have our x starts with -8 actually. So yeah, so it looks like this one starts with -7, so that one's out. All right, this one it looks like it starts with -9, so that one's out. All right, so here we have -8. All right, so this one starts off well. All right. And then it goes till x equals 12. And my y should equal 10. So that's probably our best candidate so far. Yeah, because this one, it looks like your x goes up to 13. So yeah, so we're looking at C. All right, so then the domain is going to be your x values. So the lowest value that I can have for x is -8 up to 12. And that is inclusive, so you use brackets there. And then the range are going to be your y values. So my range is going to be from 6 to 10. And again, we're using brackets for both of those as well. All right. Okay, so the next one is solving by eliminating a parameter. So here we have a set of parametric equations, and we want to end up with a linear equation. Here we have y in terms of the variable x. All right. So here we have x equals 6t minus 7, and we have y equals 5 minus 6 times t. All right. So here we're going to have a line. So spoiler alert, it's going to be a line. So that's the answer to one of your questions right there. So there, I'm giving you an answer. All right. But yeah, so to determine what that line is going to look like, we just need to solve for 6t or solve for t. Either way, you'll end up with the same thing. So to do that, I'm just going to add a 7 to each side. So we have 6t equals x plus 7. Right? And I'm just going to plug this x plus 7 in for 6t in my equation for y. So now we have y in terms of x is going to be 5 minus x plus 7, which is going to be negative x. And then we're going to have 5 minus 7, which would be minus 2. So we have y equals negative x minus 2. And it's going to be a line. And in this case, there is no boundaries for a variable t. So it's going to be from negative infinity to positive infinity for my domain, and likewise for the range. All right, and finally, here we have an application of these parametric equations. So one of the places that these parametric equations come into play is when dealing with, again, projectile motion. All right, so we have x equals v sub 0 cosine of theta times t represents my x location. And we have y, so my horizontal distance. And then we have y equals negative 16t squared plus v sub 0 sine of theta t plus h sub 0, which is going to represent my vertical displacement, or my vertical distance for my projectile there. So yeah, so the rest of this kind of just setting it up. So yeah, so you have an archer shoots an arrow from a height of 9 feet. All right, so that represents my initial height. An angle of 30 degrees, so that represents my theta, with a velocity of 280 feet per second. So that represents my initial velocity there. All right, so we have my parametric equations. So we have x equals v sub 0 cosine of theta t. So my initial velocity is going to be 280 cosine of 30 degrees times t, which cosine of 30 is going to be, I think that ends up being square root of 3 over 2. I think that's what we end up with. Yep. So here the 280 and the 2 will cancel. So I have 140 square root of 3 times t. And yeah, so let's type an exact answer using radicals as needed. So yeah, so we have 140 square root of 3 times t. If you use a decimal approximation, I will go ahead and count that. So I don't really care too much about the form you use there, but I am going to stick with the form that they asked for in this practice. But Again, if you use a decimal approximation, that's fine. I'll take that into account there. All right. So then we have y equals negative 16t squared plus my initial velocity, which is still 280, times the sine of 30 degrees times t, plus my initial height, which is 9 feet. All right, so you have negative 16t squared, and then the sine of 30 is going to be 1/2, so you have plus 140 times t plus 9. Negative 16t squared plus 140 times t plus 9. All right. Yep. All right, so then it's asking for the graph here. All right. So in this case, our x is going to start at 0, so that illuminates B. All right, so now we have A, C, and D. In fact, it looks like C might be out as well, since that looks like it starts past 0. All right, and looking at this, so yeah, so if this is 600, that means each tick is going to be, I don't know, 150 it looks like. So yeah, so if our initial y, so when t equals 0, our y is going to be 9, which is not D here. So it looks like A is going to be the one we're looking for. All right. So yeah, so let's see how we did here. All right, perfect. So there you go. So again, that's just how I would go about answering the questions. Hopefully you found this helpful. Yeah, so good luck. Have a great day, and I'll talk to you later. Bye now.